Hello everyone. Today we are going to learn the first part of Lecture 9, the perception system of industrial robots. 1. Course leading. How can an industrial robot perceive its own state and the position of a target in its work, so that the end effector can accurately work to the designed position? And how can it perceive the shape and the color of external objects? Whether there are obstacles around the object and other environmental information. All the above are the contents discussed in this lesson. 1. The perception system of industrial robots. The perception system of an industrial robot is similar to that of human, which can perceive image information, frequency information, pressure information, odor information, temperature information, balance information, and other. The core component of robot's perception system is the sensor, which can transform various physical information into electrical signals through physical and chemical means. Generally, sensors can be divided into internal sensors and external sensors according to the purpose and the scope of applications of the sensors on the robot. 2. Internal sensors. The sensors used to detect the robot's own state, such as the angle between the arms, the position, speed, acceleration, etc., and the robot during movement are internal sensors. 1. Function of internal sensors. The main functions of internal sensors are as follows. 1. Detection of specific position and angle. To detect a predetermined position or angle, you can use two states of on or off to detect the starting, origin, limited position, or exact position of the robot. 2. Measurement of position of angle. Sensors that measure the linear and angular displacement of robot joints are essential components in the robot position feedback control, including potentiometers, resolvers, and encoders. As shown in Figure 1, potentiometers, resolvers, and photoelectric encoders. Potentiometer can measure linear position. A resolver and photoelectric encoder can measure rotation angle. 3. Measurement of speed and angular velocity. The most common speed and angle sensors are tachyon generators or speed sensors and ratio generators. Among them, the tachyon generator that measures angular velocity can be divided into DC tachyon generator and the induction AC tachyon generator according to its structure. As shown in Figure 2, is a tachyon generator. 4. Measurement of acceleration. Acceleration sensors include strain gauge acceleration sensors, servo acceleration sensors, pure induction acceleration sensors, and other types of acceleration sensors. As shown in Figure 3, are strain gauge acceleration sensors, servo acceleration sensors, and piezoelectric induction acceleration sensors. 2. Position sensors. The position sensors includes position and angle detection sensors. Commonly used position sensors are angle sensors and digital sensors. The analog position sensors commonly used on industrial robots, rotary encoders, inductive synchronized potentiometers, and digital sensors include photoelectric disc, encoder discs, and gratings. 3. External sensors. The sensors used to detect the environment and object conditions of robot are external sensors, such as judging the shape and the spatial position of object being grasped by the robot, whether there are obstacles around the object being grasped, and whether the object being grasped has slipped, and so on. 3.1 Types of external sensors. Tactile sensors. Generally, the sensor that detects the sense of contact, pressure, touch, and proximity generated by direct contact with the outside is called the tactile sensor of robot. Second, force sensors. Force perception refers to the perception of forces experienced in the movement of fingers, limbs, and joints of robot. It mainly includes wrist force, joint force, and bearing force according to the load of measured object. Force sensors can be divided into load sensor, torque meters, finger sensors, and 6x force sensors. When electing a force sensor, firstly, pay special attention to the rated value. Secondly, in the normal force control of a robot, the accuracy of force is of little significance, and the most important thing is the resolution. 3. Distance sensors. Distance sensors can be used for robot navigation and obstacle avoidance, as well as for object positioning in robot space and determine its general shape characteristics. There are generally two types of distance measurement methods commonly used at present: laser distance measurement and ultrasonic distance measurement. 4. Other sensors. In addition to external sensors of robot described above, auditory sensors and taste sensors can also be installed according to special purpose of the robot. These robot sensors are mainly used for specific research, marine resource detection, or food analysis, firefighting, and other special purposes. 4. Sensor fusion. In order to effectively use this sensor information, it is necessary to use some form of synthesis and fusion processing of sensor information. Various forms of processing systems for different types of information are sensor fusion. Sensor fusion technology involves new theories and new methods in the fields of information detection and control, such as neural networks, knowledge engineering, and fuzzy theory. 4. The selection of sensor. The selection of sensor depends entirely on the work needs and application characteristics of the robot. The requirements for robot sensor system are the basis for selecting the robot sensor. First, general requirements. The general requirements of robots for sensors are as follows: high precision and good repeatability. Whether the robot can work properly and accurately often depends on the measurement accuracy of the sensor. Good stability and reliability ensure that the robot can work stability and reliability for a long time, and try to avoid malfunctions during work. Strong anti-interface ability. The working environment of industrial robots is often harsh. The sensor used should be able to withstand certain electromagnetic interface and vibration, and be able to work normally in high temperature, pressure, and pollution environment. Lightweight, small size, and easy installation. Second, specific requirements. 1. Adapt to the requirements of processing tasks. Different processing tasks have different requirements for robot sensors, which can be selected according to work characteristics. Second, meet the requirements of robot control. Robot control requires the use sensors to detect the position, speed, and acceleration of robot. Most robots use position sensors as feedback elements in closed-loop control, and the robots compensate and control their motion errors according to the feedback information of the position sensors. Third, meet the requirements of the safety of the robot itself and the safety of the robot user. The above is all the content of this class. Finally, let's summarize the content of this class. In this class, we learned about the internal sensors and external sensors of industrial robots, and learned about the function of selection requirements of sensors. Thank you for watching. Goodbye.